Alright, today we are going to be reviewing angles and triangles. We're going to start off with reviewing some information and vocabulary from 6th and 7th grade. Then we're going to progress into new content that we'll be seeing in 8th grade. The first thing that I want to go over are the different types of angles. So first we're going to talk about the different types, angle types, classifying angles, if you will. All right, here's the first one. It's got this little box right here in the corner. This angle, if you remember, is called a right angle. And it is a right angle that measures exactly 90 degrees. All right, this angle is called an acute angle. An acute angle. It measures less than 90 degrees. It's a cute little angle. A cute little angle. So this angle measure right there is less than 90 degrees. Next, we have an angle that looks like this. This angle measure, see how big it is? It's called an obtuse angle. You can see from comparing it above, an obtuse angle is larger than 90 degrees, but it's also less than 180 degrees. So it's larger than 90 degrees, but less than 180 degrees. And the last angle that we're going to talk about in this section of our notes is called this one. It is a straight line, and we call that a straight angle. Easy to remember because it's a straight line, a straight angle. And it measures exactly 180 degrees. All right, the next thing we need to talk about is how do we name angles. So next we're going to talk about naming angles. So if I have an angle here, and it works for any kind of angle, whether it's obtuse, right, or acute, I can name it the same way. So here we have an angle. This is an acute angle, right? And we've got some points along there. Well, the first way I can name it by its vertex. The vertex is the point where the two rays meet in the corner. So I could label this angle B. And this is the mathematical symbol for angle. It looks similar to a less than symbol. And we read that as angle B. Or I can measure it by its three common points. I could call this angle A, B, C. And it is important about where the vertex point is located. If you notice here, the vertex is listed in the middle. This right here is the vertex. The vertex of the angle is always listed in the middle. So I could label this angle ABC. I could also label it angle CBA. So angle CBA. As long as that vertex is in the middle. Okay, so there's two ways to label it, by just its vertex or by the 3 points that are listed on the angle. All right, the next part we need to bring up is some vocabulary. These are going to be the angle pairs that you have studied previously in 6th and 7th grade. So we're going to start with angle pairs. Now in this unit, we will be learning some new angle pairs, but first we want to start back with refreshing our memory from 6th and 7th. All right, the first one is called complementary angles. Complementary angles. Complementary angles are two angles that together make up a right angle. So two angles that when you put them together, side by side, they make a right angle. And we remember a right angle is 90 degrees. So for an example, I may have this angle here that measures 30 degrees. I'm going to come bring it out here because it's a little small. And then I can have this second angle that measures 60 degrees. And if you can see, 30 plus 60 equals 90. And this does outline to be a right angle. I could also have another example where I have that right angle split right in the center. So then each acute angle would be 45 degrees. All right, I'm going to turn my paper over because I'm out of room. I can't get the next section in the middle of this. All right, so we're still into the section of angle pairs. Angle pairs continue. All right, so we talked about complementary. Now we're going to be talking about supplementary. Supplementary angles. Supplementary angles are two angles that together make a straight angle. And if you recall from earlier, a straight angle is exactly 180 degrees. All right, so let's do an example here. We can have an example that looks like this. So I have my first angle right here, my obtuse angle, measures 157 degrees. Now my acute angle, in order for them to be supplementary, my acute angle would have to be 23 degrees. Because 157 plus 23 equals 180. I could also have a straight angle that is cut in half perpendicular. So I have a right angle here and a right angle here. Each angle is 90 degrees. Again, 90 plus 90 is 180. Now, I don't know about you, but when I was in school, I had a lot of trouble remembering which was which. I knew there was such a thing as a complementary angle, and I knew that there was a thing called a supplementary angle. But I had trouble remembering which one was the 90 degree and which one was the 180 degree. And I'll never forget, a teacher once showed me this little trick that I'm going to show you right now. A complementary angle, she was like, Jenna, we're just going to take and turn this into the number 90. See that? The C becomes part of my 9 for 90. The S, I'm going to turn it into an 8, and it becomes 180 degrees. Complementary, 90 degrees. Supplementary, 180 degrees. All right, now let's move into triangles. Let's refresh our memory about triangles. One thing we must remember, put some stars by it. All angles in a triangle, and this is the mathematical symbol for triangle as well, add up to 180 degrees. Put a bubble around it, highlight it, do something so it stands out because we do not want to forget this. All angles in a triangle add up to be 90 degrees. So let's look at some examples. First, we're going to talk about the interior angles of a triangle. What does interior mean? Interior means the inside. So interior angles. An example. All right, here's my triangle. That angle is 65 degrees. This angle is 60 degrees. I'll write it out here a little bit bigger in the side. 65, 60 degrees. But we don't know this angle, angle X. Well, in order to find that out, I know that all three angles have to add up to be what? 180 degrees. Well, let's just add them up. 65 plus 60 plus X equals 180. Do a little simplifying. 65 plus 60. So 120 plus that extra missing angle equals 180. This is just a one-step equation, guys. We need to solve for X. How do I get rid of the 120? I have to do the inverse operation. So I subtract 120 from both sides. That cancels. X is equal to 55 degrees. 55 degrees. So, you do it. 180 minus 120. 60 degrees. 60 degrees. Because 60 plus that 120, if I substituted in 60 plus 120, equals 180. So the measure of angle X is 60 degrees. All right, now let's do one that you can try. Maybe we'll do this one as an obtuse triangle. Maybe this angle right here is going to be 40 degrees. This obtuse angle right here, let's say it's 115 degrees. This acute angle, let's call it angle P. You take a moment, pause the video, see if you can find out the measure of angle P. All right, we know that all three of these have to add up to be 180. So 40 plus 115 plus P equals 180. 40 plus 115, let's simplify this. 155 plus P equals 180. Isolate your variable, get P by itself, so we subtract 155 from both sides. P is equal to 25 degrees. P is equal to 25 degrees. Now to double check ourselves, we could just add them all up. 40 plus 115 plus 25, does that equal 180? Yes, it sure does. All right, so now that we've talked about how to find angle measures of interior angles of a triangle, now we need to move and talk about exterior angles. Exterior meaning outside, so these are angles that are outside of our triangle. This is what's new in 8th grade. All right, so let's make a triangle. We can make it an equilateral triangle where every angle could be 60 degrees. And I'm just writing my degrees outside of the angles for you. So that way you can see it in the notes. It gets a little bit small. But see how this triangle is here? I'm going to take this base and I'm going to extend it. Do you see that when I extend that base, it gives me an obtuse angle right here? This one, it gives me an obtuse. All right. We're going to call that obtuse angle, we're going to call that angle X. And I want to know, what is that angle measure? What is that angle measure of angle X? Well, what's happening here? Isn't this a straight line? The same thing as a straight angle? That's 180 degrees. So if I take this acute angle right there, plus this obtuse angle, what does it have to equal? It has to equal 180 degrees. Because together, these two angles make a straight angle. They make a straight angle. So by knowing that they make a straight angle, I could take this 60 degrees plus the measure of angle X, and they must equal 180 degrees. Again, it's a one-step equation. Subtract 60 from both sides in order to isolate my variable. X is equal to 120 degrees. So the measurement of X, it's an obtuse angle that's bigger than 90. It seems reasonable. X is 120 degrees. But did you know there's another way I can even calculate this? Do you see these two angles right here, these opposite angles? My exterior angle is here, not the angle next to it, but the two that are on the opposite side of it. What happens if I add these up? Add up the two opposite angles. Add up the two opposite angles. Well, that one's 60 and that one's 60. 60 plus 60 equals 120. Guess what? They are the same answer. So we have two strategies here. We could have found the angle of measure X. I can use what I know because they're supplementary, or I can just look at these two opposite angles, add them together. All right, let's try another example. Maybe I have another triangle where the base extends. I know that this angle right here is going to be 64 degrees. This angle right here is going to be 45 degrees. I don't know this angle. We're going to leave it blank. We're going to leave it blank. But I still want to know, what is the measure of angle X? What is the measure of angle X? Well, again, I can use both of these strategies to figure that out. If I don't know this, I can kind of put a question mark right there. And I know this angle plus 64 plus 45 has to equal what? 180 degrees. That's how many degrees are in a triangle. So 64 plus 45 plus, I don't know what that is, equals 180. I'm not using X because X is already here for this angle. I could put another variable if I want. I can leave a question mark. Same thing. So 64 plus 105. 109 plus that missing angle equals 180. I need to get that missing angle by itself. So I need to subtract 109 from both sides. So that missing angle is equal to 71 degrees. So that means that missing angle right there is 71 degrees. Now, if I know that that's 71 degrees, I know 71 plus X makes that straight line. So I could say 71 plus X has to equal 180 degrees, that straight line, that straight angle. Again, we're solving, trying to get X by itself. Minus 71 from both sides. X is equal to 109. Now, we could also use our other strategy of using the opposite angles. This is an exterior angle. An exterior angle is congruent to the sum of the two opposite angles. So I could take 64 plus 45. Together, those equal 109 degrees. Looky there, same answer. It works every time. It works every time. All right, let's do another one that you can try. Let's do one more that you can try. All right, this time, I'm going to have my triangle. And instead of extending the base, I'm going to extend this side measurement. It's the same thing, it's just kind of turned around, flipped around. So this angle right here, we're going to say that that angle measures 75 degrees. This angle measures 36 degrees. I don't know this one, but I'm going to tell you that we are trying to find this exterior angle. So given the information you know, you can pick whichever strategy you like. I want you to solve it, see if you can find the value of x. When you're ready, come back to the video. All right, let's see what we can do. Well, I don't know this angle measurement, so I could say 75 plus 36 plus the angle I don't know, all have to add up to be 180 degrees. 75 plus 36 is 111, plus that missing angle equals 180. I'm solving for that missing angle. I need to subtract 111 from both sides. So that missing angle measurement that we don't know is equal to 69 degrees. So that means that 69 degrees goes right there, 69 degrees. So now if I know that this is 69 degrees, I know that 69 plus this angle x, they make that straight line. Both angles make a straight line. What does a straight line, a straight angle have to add up to be? You got it, 180. So now I can say 69 plus x, 69 plus x, this angle plus this angle, has to equal 180. Subtract 69 from both sides. X is equal to 111 degrees. So the value of x is 111. Now, I can also add up my opposite angles. Here's my exterior angle, not the angle next to it, the opposite two. So these angles right here. 75 plus 36, 111, same answer. Same answer. All right, we have one last example. I have to turn my page. Last example of the day. All right. Here's our last example. I'm going to have a triangle. I'll extend the base. I know that this is 30 degrees. I know this is 92 degrees. What is this angle, the value of x? How would we solve that? Think about that. I know that all the angles here have to add up to be 180, but do I have all three angles? No. How could I get this angle? I have to get this angle in order to be able to find our missing value of x. How can I get this angle? Yes, look right here. It's a straight line, a straight angle. 92 plus this missing angle has to equal what? You got it, 180 degrees. That makes a straight angle. So 92 plus that missing angle has to equal 180. All right, let's solve it. I need to get that missing angle by itself. So I subtract 92 from both sides. My missing angle, that's question mark. Let me make that a little bit better for you guys. Kind of looks like the number 2. That missing angle is going to equal 88 degrees. 180 minus 92, 88 degrees. 88 degrees. So now I know that that is 88 degrees. Well, now do I have enough information that I can find the value of x? I sure do. I know that all 3 of these have to add up to be what? How many degrees are in a triangle? You got it, 180 degrees. So I can say 30 plus 88 degrees plus x equals 180 degrees. Let's simplify this a little bit. 30 plus 88, 118 plus x equals 180. All right, now we just solve for x. Isolate it. 118 subtracted from both sides. X is equal to 62 degrees. 180 minus 18, 62 degrees. All right, so we started out talking about the different types of angles, then angle pairs. Then we moved into triangles, both interior and exterior. You have to take what you know from that vocabulary from 6th and 7th grade and apply it to problems like these, where we're finding a missing measure, whether it's an interior missing measure or, like what we had back here, those exterior missing measures. All right. All right, again, this is the start of our new unit, Unit 9, which encompasses angle relationships.